Good morning, good afternoon, a warm welcome to all our attendees today from across the globe. Thank you so much for joining us today for this webinar on device-side performance analysis and optimization of mobile apps. This webinar is hosted by Impetus Technologies, partners in software R&D for global technology businesses. We're excited to have you with us for the next 40 minutes or so as we discuss how the device-side performance analysis and optimization plays a vital role in the development life cycle of mobile apps. My name is Lisa Glenn, your presenter and host for this session. The featured speaker for this session is Abhijit Phatak from Mobile and Wireless Research Cell at Impetus. Moving on to what today's session is going to cover. The global mobile applications market is growing very rapidly, and according to recent market studies, it's expected to reach $24.4 billion by 2015. We've noticed that all the major players in the market are creating mobile versions of their offerings. Now, there's numerous applications available in the market that may suit end users' purpose. However, the ideal option will be the one that makes efficient use of the device properties, such as storage and processor, as well as one that provides good functionality with great performance and speed. In our session today, we're going to share with you how you can optimally leverage platform-specific functionalities while creating mobile applications. We'll discuss the various ways to analyze device-side performance of mobile apps and the various optimization techniques to address performance bottlenecks. We'll also discuss some real-world examples of device-side performance optimization. So let's go ahead and take a look at some of the device-side performance challenges. In the dynamic mobile market, the number of handsets and operating systems are continuously increasing. The handsets range from basic phones to the feature-rich smartphones and now the mighty iPad and other tablets. These devices differ in operating systems, screen sizes, memory, and other hardware parameters. Furthermore, all the operators, manufacturers, and online stores have their own specifications from the applications they would like to promote. Then there are the devices that can be used on the portrait or landscape mode, as well as touch and non-touch. Mobile handset manufacturers such as Apple, Nokia, Samsung, LG, Motorola, etc. provide operating system-based handsets. Dealing with this vast majority of configurations would require a thorough understanding of platforms and their best practices. Plus, working with large teams and having a talent pool with different levels of experience and expertise may also create a lot of chaos for you. With the technology maturing over subsequent generations, the devices are now coming with enhanced capabilities including CPU, memory, and things like that. So if in case you're developing a complex application and have started using CPU cycles, you should also take the memory into account. Otherwise, it's a possibility that your application could develop some serious issues that would not be easy to resolve at a later stage. These devices can also vary in battery life, Wi-Fi capabilities, touch, multi-touch, and GPS. Your application must use the limited device capabilities in an efficient manner. Say your application wants to access GPS to show immediate updates to the user. But in such a scenario, the GPS should not adversely affect the device battery. Now, with highly complex applications that are being developed nowadays, it's imperative to manage the device memory and CPU efficiently. You may combine the limited capabilities of the devices with the inherent latency of mobile networks and go on to discover further challenges to achieve good performance out of the application. Furthermore, mobile devices are now coming with high quality of graphics, 3D, cameras, animations, and gaming options that further utilize the memory and other capabilities. It's essential to consider these factors while developing your application. Also, choosing the development methodology plays an important role on performance analysis. Here's an example. What should be the difference in your approach to develop a mobile application vis-a-vis a gaming app. Now, in the case of a gaming app, there are very few screens, but the logic is large, whereas in the case of other apps, there's more screens, but the logic is not as complex. I'd like to now ask you all a question that you can actually see on the right portion of your screen. We would like to know, what has been your biggest challenge in the device-side performance testing? Your options are diversity in handsets, the difference in screen size, variations in CPU and memory, device features such as GPS, camera, etc., and application development methodology. We would love your input, and you can actually choose more than one answer, and you have a total of 30 seconds to respond now. Well, it looks like we have the results, and it looks like more than 50% of the respondents have chosen variations in CPU and memory as their biggest challenge. The next biggest challenge is diversity in handsets. I would like to ask our expert speaker for today, Abhijit, to comment on the poll results. Hi, Abhijit.
Hi, Lisa, and hello, audience. Thank you for joining us in this session today. I totally agree with the poll results. All mobile applications nowadays utilize the rich features of the device so that they can process big images or can stream media from the server. And because of that, the application has to efficiently deal with CPU and memory to properly exploit these features.
Great, thanks, Abhijit. So, having discussed the device-side performance challenges, we're now going to go ahead and focus on the various advantages of performance optimization of mobile apps. As you can see on the screen, we've listed some of the advantages of performance analysis and optimization. Mobile devices have limited resources. Take battery capacity, for example, which requires the developers to carefully manage the resource utilization. Now, to optimize the resource utilization, developers should understand the trade-offs between battery life and performance. It's very difficult to determine the results of architecture modifications until the complete software has been implemented. Due to this reason, one has to make more investment after the complete development lifecycle and revamp some parts of the code to get the desired results. The architecture choice, however, is dependent on the architect's or developer's experience and discretion. Let me give you an example to explain this a little bit better. In the case of implementing listener approach, you would not need the CPU cycle if you're waiting for a certain event to occur. However, you would need recurrent CPU cycles if you're checking the event after a particular frequency. We'll now talk about what really happens if your application is not performing as per expectations. So, if the user is not happy with your application's performance, he may not want to use it again and may also write a bad review. But worse, if this poor performance is detected at the later stages of product development, it would require a lot of effort to address these bottlenecks. It may even need architecture changes and might necessitate revamping the entire code, thereby affecting the time to market. Moreover, if the application was built on multiple platforms, then we would need to test it on all these platforms. Let me explain this with an example. Say, if an application is targeted to all the Java variants, then they should share a common business logic. In case this is ignored during the development phase, you would need to repeat this step on multiple platforms. Now, on this next slide, we're sharing with you the important factors that must be considered while analyzing application performance. Let's talk about these parameters one by one, and we're going to go ahead and start with the process. Now, this is one of the most important factors, as procuring the information about running processes would help analyze their importance. Furthermore, it enables us to acquire all the packages that have been loaded into these processes. The next important parameter is the CPU information. This is used to capture the CPU state at various stages of the application. This helps us analyze CPU total, CPU idle, and CPU usage for various activities. This information also helps us to understand which activity is tricky and would need to go back and have another look. Let me now tell you about memory information. This characteristic shares particulars about the memory usage in an application, including the total private memory, total private dirty, total shared dirty, and etc. These details are available on a per-activity basis, and one can analyze the memory usage of each and every running activity through this. Let me explain this. Say your private memory usage is increasing for any particular activity. In such a scenario, you would need to take a look at that activity and figure out if any object is consuming a large chunk of memory. And if it is, you need to check if it's returning that memory after the usage. The next parameter is the battery. Now, the battery consumption is directly related to the CPU usage while running any application. We can analyze the battery usage of an application, and if this usage is more than the specified threshold, we should have a look at all the long-running operations and multiple threads. I want to talk to you now about the device info next. We believe that the device information is very important to determine the application's performance. The devices nowadays are loaded with GPS, hardware acceleration, cameras, and several other rich features. It's important for us to determine the impact of these parameters before the performance analysis. The next parameter will be the debug info, which provides statistics on the object counts in the system globally and internal to the app. It also provides information about GC invocation count, heap allocated size, threading information, etc. One can analyze the number of GC occurrences to ascertain whether it will release the memory. If the GC occurrence is frequent, that implies that there are issues in the app performance. Also, one can analyze the number of threads concurrently running into the system. In case it's exceeding a particular limit, then we should analyze whether these threads are necessary and what we can do to avoid their concurrent execution. Now, the next parameter we're going to talk about is service information. Service is a facility through which the application can share with the system what it wants to do in the background, even when the user is not directly interacting with it. By analyzing the service information, one could figure out pertinent information such as when the application was initiated by the system, number of clients currently connected to it, number of times the service crashed, and is the service currently running or not. This will help us know the overall impact of this parameter on the device. One can also compare other parameters while running the service and without the service. Say if the app performance was going down when the service was running and recovers once the service is terminated, then the problem lies with the service and not with the application. So what options do we have for the device-side performance engineering of your mobile apps? Let's check it out. Now, there are multiple tool options that are available for different platforms that can help you in analyzing the performance and memory usage of your mobile applications. These include TraceView and Eclipse Memory Analyzer for Android, J2ME Profile for Java phones, JDE Memory Analyzer for BlackBerry, and Instruments for iOS. These tools also provide some information about memory usage, CPU cycles, etc. It also helps debug the application and conduct a performance profile. However, if you want to determine the problem area of your application, we recommend using small stubs. Let me explain this. Say your application is crashing after certain events, and there are around 4 or 5 different activities involved in the event. Now, you may use small libraries to ascertain which activity is the bottleneck for the system and resolve that issue. So, after discussing the options, let's now look at our recommended performance analysis approach. So, we discussed in the previous slide how we can use tools and write stubs to identify the problem areas. These stubs can be integrated as a library to the original code base. They also have the capability to capture various parameters on the device while the target application is running on it. The stubs can provide details such as services, tasks, memory, CPU, device, debug, and battery information. Based on these figures, you can determine where your application is lacking and go ahead and take the appropriate measures to address the performance issues. So what are the various steps involved in analyzing the performance of your mobile apps? First, you identify the bottlenecks in the hardware infrastructure, say the limited resources of the device, or whether your network is likely to be GSM, CDMA. This could be analyzed by the libraries, and you can also get an estimate of how much resources would be required by your application. Then, you can measure the response time for various transactions that require RMS or server access. After this, you can gauge the effect of battery standby or talk time by using performance gathering libraries. These libraries can really help us instrument specific scenarios on the device and provide the answers that we're looking for. Lastly, you must ensure that your application does not cause harm to the other applications or data stored on the device. Once all these parameters are captured on the device, the libraries would extract, collate, and analyze the parameters to get the exact information about the system's performance. Now, after analysis, it would generate a complete report, sharing details on the performance bottlenecks that we can subsequently address. Our expert speaker for today's session, Abhijit, will now share with you how you can enhance the performance of your applications. Abhijit?
Thanks, Lisa. I will now share with you the optimization techniques that can be used to enhance the performance of your applications. These optimization techniques will be directly mapped to the challenges that we discussed in our previous slides. We will start with UI-independent layouts, design, and portability. So this is directly related with our challenge which we defined earlier, that is the diversity in handsets, difference in screen sizes, and touch and multi-touch. Now, the applications developed on Java can run perfectly on most of the devices, but the variations in device implementations may make this task more complicated. While developing an application, you should consider all these factors and produce a no porting or less porting build. Working on applications that need support for touch, non-touch devices is again a complicated task. The code structure and architecture should be written in such a manner that it can seamlessly work on both types of handsets with minimum changes. Let me give an example. If we are talking about key events versus touch events, we should write a controller logic of screens in such a manner that both types of events produce the same results. While developing an application for any platform, you should write resolution neutral code so that by changing some of the resources, application can easily run on other devices. Applications should avoid any hard-coded coordinates, logic, and resources. Instead, they should derive the height and width at the runtime and then draw the actual screen. This way, most of the UI-centric porting efforts will be reduced. If this factor has not been considered in the early development, then the overall application size will increase. Your application would require a lot of conditional execution to see what kind of UI objects it would draw, and may also reduce the overall performance of the system. We will now talk about the next technique, which is the proper usage of MVC. This will directly address the challenges posed by application development methodology. We recommended that while designing the application, you should write a platform-independent design so that the code can be directly utilized on other platforms. If we talk about currently available platforms, we can largely divide them into two variations, which is Java and C++. Now, the J2ME, Android and BlackBerry belongs to the Java category, whereas Brew, Symbian and iPhone belongs to the C++ category. So, while writing your applications in J2ME, you should consider the fact that its architecture and the business logic can be directly used on BlackBerry and Android, and would only require UI-related changes in these technologies. However, don't forget that the application design should consider device memory, keypad, camera, and other hardware-related features such as GPS, accelerometer, etc. If you have failed to follow the right design practices, then your application may have large binary size and unstructured code. As a result, the app may start crashing at various stages and will not be usable. Let's take up optimized communication now. So this challenge is directly related with our challenge which we defined in the earlier slides, that is 3G options and Wi-Fi capabilities. So we know that the mobile devices are capable of providing good bandwidth, and to utilize its capabilities, communication should be highly optimized. Applications should take a call on the requirement of continuous connection to the server by using TCP socket. Ideally, this should be avoided due to its high consumption of resources. Alternatively, push-based notification methods may be used. In this approach, the client won't make continuous connection to the server. Instead, the server would send a command to the client that the new message is available, and as a response to that, the application will contact server for new updates. Additionally, to reduce the round trips between various screens, applications can implement objects and data caching mechanisms. The applications can use record store for permanent data storage or use data structure for temporary storage. These cache objects can be accessed till the application is running and will be destroyed once the application exits. If the application is using any standard protocols such as VNC, IMPS for communication, then it should use lightweight protocols and minimalistic functionality. All the standard protocols consume the limited device resources and are not meant for mobile devices. Ideally, using the scaled down versions of these protocols will help reducing the data transfer and will increase the overall functionality of the application. I would now tell you about the next critical optimization technique, which is auto selection of most preferred mode. While designing applications, you should advise your project team to look into the design considerations of available options. The application should look for preferred communication options like GPRS, Edge, and Wi-Fi. Since Wi-Fi is the fastest data transfer channel as compared to others, so applications should seek its availability before sending any data to the server. And if Wi-Fi is not available, then it should check for 3G, Edge, or GPRS. Let us now talk about the next parameter, which is memory management with the help of weak references. This technique helps resolve application development methodology challenge. We have seen that the memory of mobile device has considerably increased over the years. However, the RAM in most of the devices is still quite low. If in case there are multiple applications running simultaneously on the device, then it is very likely to have memory issues. Moreover, there can be performance issues if your application is using more than 25% of available memory. So the weak reference objects are usually the first candidate for garbage collection and release the memory as soon as possible. We will now talk about the next optimization technique, that is lazy loading. Now, this directly hits the problem created by the different types of processors and hardware. So what happens when the application is dealing with large amount of information and the bigger data chunk is being loaded, displayed on list or table view. In such scenario, the performance of the UI layer can be nightmare. This kind of implementation could affect the app performance as well as the device. However, this problem can be addressed by lazy loading of resources, as it will facilitate faster availability of application screen to the users. Moving on to the next parameter, which is worker thread. For any application, its responsiveness is an important attribute, which ideally should not be compromised at any cost. Now, every application can be divided into two parts, the UI layer and the business logic layer. To maintain this separation, all the time-consuming operations related with the business logic must be implemented at worker thread. There should be appropriate synchronization between UI and business logic threads, and the UI layer should be completely available for interaction with end user.
Great, thanks Abhijit, that was really helpful. I'd now like to share with our audience how we successfully planned, analyzed, and optimized the performance of one of our clients' mobile apps. Our client was a leading financial services provider and was developing a mobile application that could help its users to fill out their tax returns. However, there were some issues in the application performance. The application was not usable after its fourth or fifth run, and moreover, the screens were also taking considerable time to actually load onto the screens. The app was also crashing after repetitive runs and consuming more memory than its specified threshold. We inserted a small library implementation in the application to identify the problem areas and found out that the issues that were directly affecting the CPU, battery, and memory consumption of the device. We also noted that about 90% of activities were prone to memory leakages at various stages. This app was using image processing algorithms, and we reinvented the algorithm to reduce CPU and memory footprint. To increase the UI throughput, we used a multi-threaded approach and shifted the background activities to another thread. After these steps, the UI layouts were being shown as and when requested. With the help of lazy loading, we reinvented the UI architecture and increased the overall throughput. But we also had to address some memory leaks. The major problem that we identified was that the app was passing the instance of one activity to another. If in case, due to any particular reason, the second activity leaked, it would not allow the garbage collection of the previous activity. We resolved this issue with the help of application context. So what were the benefits of our approach? Well, we managed to increase the overall life of the application, enhance the loading and processing speed, which in turn led to a happy end user. Let me share with you another case study. Now, another one of our clients is a leading media broadcast service provider company and was developing an application that could show live TV on mobile devices. The client was facing some problems with their mobile app, such as complying with the various network protocol usages. There were also some issues related to the smooth transition of audio and video together without interruption. The client also wanted to reduce the consumption of battery and CPU cycles while running this app. Impetus proposed that the client create custom media source implementations, which would then feed to the media player. We used the scaled-down versions of RTSP, RTP, and RTCP protocols. We also enhanced the audio-video synchronization with the help of a multi-threaded approach. Now, with our approach, we help the client increase the battery life and maintain the audio-video synchronization without reducing the picture quality. We derived our performance analysis and optimization approach from the Impetus mobile maturity model. So as you can see on your screen, the model has 20 attributes distributed across 3 levels. These attributes are individually considered in the various phases of mobile product development For example, analysis, design, development, deployment, and post-deployment. The attributes under these phases are acknowledged in a manner that gives direction for the development at a later stage. This model ensures that all the parameters and their implications for a given set of mobile requirements are handled adequately and at the right time. Adopting this mobile maturity model while designing and creating a mobile application helps lay out critical expectations, enables design and development in sync with the features that really matter. Now, on the slide you're about to see, you can see some of the significant takeaways of today's session. The first one being that your application should not harm the existing applications, data, or any other device capabilities in any manner. It should optimally utilize the CPU and memory as per the defined threshold. Next, we shared with you some parameters such as process, CPU, memory, and debug information that should be taken into account for thoroughly analyzing the device-side performance of your application. We also shared with you about the advantages of using small stubs instrumented into the original code base. The stubs can provide details such as services, tasks, memory, CPU, device, debug, and battery information. Now, based on these figures, you can determine where your application is lacking and then take the appropriate measures to address the performance issues. Abhijit also shared with you some excellent optimization techniques earlier in the session that you can use to enhance the performance of your mobile apps. And lastly, we want to reiterate the right design of the application in the initial development stage will ultimately set the tone for how your application's performance will shape up on the device. So do your best to get that right. Well, it looks like we've started to receive some questions from the audience, and I'd like to remind you that you can use the chat panel to ask your questions. But before I take up those audience queries, I'd like to introduce Impetus Technologies to you. We develop innovative mobile solutions, software products, and technology solutions for mobile products and services companies, ISVs, and technology-enabled businesses. Our expertise spans the domains of mobility solutions, data analytics, large data management, SaaS, cloud computing, testing, performance engineering, and social media, among others. We offer technology expertise on all kinds of mobile platforms and handsets, and really provide a range of value-added services around the same. We create next-gen mobile solutions that are secure, reliable, scalable, and manageable. Well, it looks like we've got some questions here. Okay, here's the first question. We've got it now. This question is for Abhijit. The question is, when should the application make continuous connection with the server? What do you think, Abhijit?
To maintain the continuous connection with the server, one should analyze if it is really required. So in kind of scenarios where applications would need immediate updates from the server, and for those kind of scenarios, one should maintain the continuous connection. So nowadays, there are all these platforms are coming up with their own push notification based mechanism, like push notification for iOS, BBM social platform for BlackBerry, and C2DM for Android. So they already provide one communication channel open with the original server, and you can leverage that open channel to get a scenario where you would have a online connection with the server. So these technologies already provide you those kind of scenarios, and you can leverage that particular functionality to have an open connection kind of thing. But if we are talking about the application development, you should only do for some kind of applications where you are streaming from the server or showing a video directly, video and audio directly from any of the available links.
Great, that's a great question. Looks like we've got another question that came in, and this one asks, when can I say my application will be a battery smart app? What do you think?
Battery smart app is a relative term, not an absolute term. You can't say like your application is battery smart based on some kind of parameters or values. So for comparing the battery parameters, you need to compare the results without your application. So let's suppose you have developed a custom media implementation to show some of the videos onto the screen. So how would you know like your application is really a battery smart? So you can do a quick test here. So you can start your media player, native media player, and see how much time your application is running perfectly. And let's suppose your device would run out in 4 hours. Then you can run your application and see for how many hours your device is running on. If your device just ran out in 2 hours 45 minutes, then I would say it's not a battery smart app. But if your device is running till 3 hours 45 minutes and it is just a 15-minute late from the original one, I can say this is a battery smart app.
Okay, great. Got another question that came in, and this one asks, why did you use stubs to identify bottlenecks instead of profiles? Abhijit?
Yes. So if we are talking about various tools available with these platforms, you can definitely get some of the results, but not the actual crux. You were not able to know like which is the problematic activity for your application. So let's suppose we take an example. There are around 100 screens in your application and you are analyzing with a tool. So probably it would take a lot much time for you to analyze all these values which you are getting out of that. And after that, it would be very difficult for you to get an exact issue, like which activity is creating problem for you. Instead of that approach, if you use a small stub in your application which will give you complete analysis and a proper analysis for the issue, which was not catered by the tools. So by using your stub, you would know exactly what is the problem, and then you can go more deeper into that, like this is activity, this is the function, this is creating more problems for me. So I can directly hit the problem instead of looking at various places.
Okay, it looks unfortunately like that's all the time we have to answer the questions live today. We will be addressing the remaining questions that we did receive, but we'll address those through email to all the people listening today. I'd like to really thank our audience for their time today. We hope that this discussion was a learning experience for you and will really add value to your mobility initiatives. If you have any questions or would like to approach us for a free consultation, please email us at inquiry@impetus.com, or you can visit our website, www.impetus.com. Thank you all so much and have a great day.